This is the wave. The very topmost part of the wave is called the crest, while the bottommost part of the wave is called the trough. The distance from the zero line to the very top of the wave, the crest, is called the amplitude. And the amplitude is a measure of how tall the wave is. This wave has a high amplitude while the other wave has a low amplitude. Now you can see, if we look at the amplitude setting up top, our amplitude is at about 50. Now if I were to increase the amplitude up to, say, 80 or so, you can see that the amplitude has gotten higher. So the amplitude is how high the crest of the wave is from the zero line. Now, if I were to decrease the amplitude, let's bring the amplitude down to 20 or so. And now we see our wave has a very small amplitude. So this is a small amplitude that is a high amplitude. The distance from crest to crest is called the wavelength, and as with any length in the metric system, is measured in meters. And back to our wave. Now, wavelength is the distance from crest to crest. So this length is our wavelength. Now, wavelength is inversely proportional to frequency, which means that as you increase frequency, you decrease wavelength. Let me show you what I mean. I'm going to increase the frequency up to 90, and look, our wavelength is a lot shorter than it was before. So we increase the frequency, the wavelength decreases. But now if I were to decrease the frequency and look at our wavelength now, our wavelength is a lot longer. Wavelength is a lot longer with a decreased frequency. So as we increase the frequency, wavelength gets shorter and shorter. But if we decrease the frequency, wavelength gets longer and longer. So that's what I mean when I say that wavelength is inversely proportional to frequency. As one increases, the other decreases. If we have a high frequency, then we're going to have a short wavelength. But if we have a low frequency, then we're going to have a long wavelength.